Hello there, creators. I hope that you guys are good and welcome to the first lesson of Physical Sciences, grade 12, Momentum and Impulse. Right. So today we will be dealing specifically with momentum. Right. Okay. So now let us check here. What do you need in order for you to be successful in physical sciences this year? The first thing that I advise you to have is to have the examination guideline by your side. Right. So every time when I'm doing my videos, make sure that by your side you have your examination guideline as per the Department of Basic Education, right? So if you don't have it or your teachers haven't given you a copy of it, make sure that you simply go online and check for grade 12 physical sciences examination guideline. It will simply pop up there with its PDF form, and make sure that you download it, right? Okay, so now please, as I continue with these lessons, make sure that you read it or you follow through in conjunction with your examination guidelines, right? Okay, so the first thing that we are asked to do in terms of the examination guideline is to define what momentum is, right? So now, what is momentum? Okay, so momentum, this I think it's one of the simplest definitions in physical sciences. So momentum is simply the product of an object's mass, right? And its velocity, right? That's just as simple as it is. Momentum is the product of an object's mass and its velocity. In other words, mass times velocity is equals to what? To momentum. Now that means that for us in any scenario to have momentum, once we can identify mass and once we can identify velocity, therefore we are expected to have what? We're expected to have momentum. Now this is the symbol P for momentum, right? Okay, so please make sure that you know this definition off by head and off by heart. At any time you're asked to write a definition of momentum, you should be, right? So it's much easier to understand concepts when you understand the definition. Please, others try and do shortcuts and try understanding the content before understanding the definitions. But please, I beg you, try and understand first the definitions, even before moving to the deep context of what this any topic is about actually. Right, okay. So now we are done with the first point according to the examination guideline of what we need to know. Right. So what we need to check now is that, okay, now what is the unit of measurement for mass? So now that is kilograms, right? That would mean that if you are given mass in grams, the first thing you need to do before even performing a calculation on momentum is to change the m to kilogram, right? Now, what is the second thing? Velocity is measured in meters per second in your physical sciences every time, right? So now what is the unit of measurement for momentum? Now that would be kilograms per meters per second, right? So please make sure that you know these units of measurement, because if you don't write them, the person who's marking on the marker is allowed to give you a wrong. All right. Okay. So now, what is the second thing that we need to do in terms of our examination guideline? Now, the examination guideline tells us, right, to describe linear momentum. Right. So to discuss or describe linear momentum as what? As a vector quantity. Right. So others maybe might have forgotten what is a vector quantity. Now, a vector quantity is simply a physical quantity. Let me start with that. It's a physical quantity with what? With magnitude, or with both magnitude plus direction. Right. So now what is magnitude? Right. So magnitude, for example, let us say that, okay, this person was traveling at 2 meters per second, right? That 2, that number shows us the what? The magnitude, right? Then now when they tell us if this person was traveling 2 meters per second, west, right, up, down. Now that is direction, right? I hope that this makes sense. So it will make sense that every time you're asked to calculate momentum, always make sure that you include your direction. Why? Because momentum is a vector quantity, right? So it will help you in physical science to know what something is. Is it a vector quantity or a scalar quantity? So that you can know that, okay, when I write my units, must I include my direction there? Right. Okay, let me not waste any more time. I hope that that makes sense, right? If it doesn't, please make sure you pause the video and go back to understand more what I'm trying to say, right? Okay, now let us go to the third bullet according to the examination guideline of what we need to know. Now it says that we need to be able to calculate momentum of a moving object using this formula. Right. So now, for example, let us say that you are given a scenario to say, okay, a boy. So we have a boy here, and a boy runs, or a boy of mass, let's say 75 kilograms, right? Runs at a rate of 60 meters per second, right? So before attempting any question on physics or a question in momentum, please make sure first that you convert these units into its appropriate units. For example, like I said, if it's mass, make sure it's in kilograms. If it's velocity, make sure it's in meters per second. So in this case, we have mass in kilograms and we have velocity in meters per second, right? Okay. Then the second thing would be to now indicate your direction, right? So in this case, they were not specific with direction, but now our answer would need to say now in the direction of motion. So what I forgot to say is that now your velocity or your momentum will always be in the direction of motion, right? I hope that makes sense. So it will mean that if the person is moving to the right, we are also expecting momentum to be to the right. Right. Okay. I hope that is not Chinese. Right. So now let us try and attempt this question here. So if a boy of mass 75 kg runs at a rate of 60 meters per second. Now, what do we have here? We have mass. What is the other thing that we have? We have velocity. Can we calculate momentum? Yes. And what is the formula? P is equals to M times V. Now, P is equals to, what is the mass? 75. What is the velocity? 60. Right. So what you need to do now is simply punch that into your calculator. Right. So when you punch that into your calculator, you get that momentum is actually equals to what? 3,600 kilograms per meters per second. Now, what is the direction? So that would be in the direction of motion. Right. Please make sure you don't leave out the direction when calculating momentum. Right. Okay. So now that is what you need to do in terms of momentum. So for momentum, there is nothing else trickier in this. It's just as simple as I've just explained it. Right. So we'll continue on to explain your second Newton's second law in terms of momentum and the change in momentum. So moving from there, then you'd see that according to examination guideline, they now want you to describe the vector nature of momentum and illustrate it with some simple example, then draw a vector diagram to illustrate the relationship between the initial momentum and the final momentum, right? So that would be much clearer moving on, right? So for now, this is what you need to know for your momentum. I hope that this was helpful and you guys are understanding what is now happening with momentum. Follow me and join me for the second lesson on momentum and impulse. Thank you.